All right, so we're doing one more example of decay. We've done lots of growth and we're gonna do a decay as we move on to your project. So different substances are described as having a half-life, and a half-life um, basically means that after whatever that time period is, half of the material is left. So radioactive material like plutonium would have a half-life, and also drugs in our bloodstream also have a half-life. So caffeine, which is a drug, also has a half-life. And so for me, I estimate that my caffeine has a half-life in the bloodstream for 1 hour. I'm on a certain Monday morning, very, very tired, and I have a very large, very strong cup of coffee with an extra espresso shot. It contains 50 milligrams of caffeine, and I drink it immediately. That's like my time zero. I want you to fill in as much of the information about the situation as you can. There's a table. So fill in, can you fill in the values for X and Y? Can you label them? What does X represent in my problem that I described for me? And what does Y represent? And then you can give me any details you can about this situation. And then after that, your challenge is to write an equation. So I'm going to stop talking for a minute as I'm checking your responses. I'll be chatting to people. Feel free to chat me some questions or to ask them out loud, and I'll check in with you. Okay, so I see lots of people. Almost everybody has started in the X column. If you have 0, 1, 2, 3, you're on an excellent rate. And then how much caffeine did I start with? Right, that will be my time zero. And good, I have some people checking. So I'm going to be chatting to you, answering your questions that you're chatting to me. And you might need a calculator. Do you have your phone handy? If you don't have your phone handy, you could open a calculator tab. Just do a Google search. I'll show you in just a minute after I finish this chat, and I'll show you how to do that. And again, it takes me a minute as I'm scrolling through looking to see what work you've got in here.
Hey, Miss Aston.
Yeah.
Does half-life mean that it's like, what's it called, like, minusing by half each time?
It is reducing by half each time. It's not quite the operation of minus though. A rate means that I'm multiplying. And so really, so if I start out, how much caffeine am I starting out with?
500 milligrams.
Yep, excellent. And then if after an hour I have half of that, what do I have after an hour?
250.
250. And then after another hour, I have half of that, which would be,
Wait, so it just keeps doing that every hour?
yep, half, half, half. And if I think about that, really, it, when we think about operation, it is going down, but it's not actually subtracting. It's a rate, so it's multiplying. It's either multiplying by 1/2 or 0.5, which is the same as dividing. It really is.
Yeah.
That multiplication is the same operation as dividing.
Okay, thank you.
Yeah, you're welcome. And a number of things chat just came through. And I see that some people have labeled the X and Y columns on top. See if you can do that. Challenge yourself to see if you can do that. And if you're not started, well, actually, I think almost everybody has started. Let me see. There's a few people. Check your chat. Um, Make sure that you are working on this. And I'm going to go ahead and show just because it could be you're comfortable doing these numbers in your head, but we have resources if you are not. And that some people for their projects have chose some really big numbers. I had several people that have wanted to like do the world population, which is totally fine and you can do it. You just end up with numbers that you want your calculator for. Same with a lot of the money problems. So here, and actually pretty much the numbers start getting really big no matter what you do, or they start getting really small. So here, if I start with 500, I'm going to choose to multiply by 0.5. It's the same as dividing by 2. It's the same as multiplying by 1/2. And I get 250. And then I can do that again. And I can do that again. And I can do that again. And this is that idea that when we were starting out with sequences, that kind of recursive definition that we're going back and kind of doing that same process again and again and again. So we'll look at a few answers. And this one, I'm trying to see who this is. So Maddie, would you mind explaining that you put a little explanation to the side here where you highlighted your multiplier? Could you explain that?
Yeah. So in most of the equations that we've been doing, it's been multiplication.
Mhm.
So I changed it from divide like divide divide by 2 to times 0.5 because they're equivalent.
Excellent. Thank you so much. That's a great explanation. And so I'm going to see if anybody else did it a different way, which would be correct also. But Maddie's exactly right, is that when we have this, when we're actually dividing or we're having a decay, what we're really doing is we're multiplying. We can express as multiplying by like a decimal or a fraction that's less than one. Um, and so again, so if you, great if you got started here and you see the pattern, right, of that kind of increase. And then here, I have very similar, and somebody has question marks here, and this is great. And you can delete all those question marks because you are spot on, right? X was my hours. Y is how much coffee is in the bloodstream. And by the way, most substances in the blood do actually follow this exponential decay. And so that's a real thing. And that's really how we would figure it out. It doesn't go down a set amount. It kind of like flattens out. It curves this out. And actually, I think I might show you guys a graph of that. And when we do just be careful. If we're doing half, we're going to be multiplying by half. So half of that, which would be 250, right? And then half of that would be 125, and then half again, right? Decreasing by half each time. And here somebody wrote the equation with the fraction, which is the same. Okay, on a graph, later on in your project, you're going to be going to Desmos. I will show you here. There's also a video on Google Classroom. The graph is the part that's a little bit tricky. And if you don't get help today on your graph, and you can watch the video. If you need more help after that, you can come to office hours. So when you go to Desmos, the link is on your doc. It will take you to this graphing calculator. I'm going to type in the equation we just had. I type in y equals, and I started out with 500 milligrams of caffeine, and then I'm multiplying. I'm going to type shift 8, which is a times, and then I'm going to do 0.5, and then shift 6, which will give me this exponent, and then x. So I can see here that my graph is sort of like off over here on this chart. And something I can do to fix that is I can actually hit this little wrench button here, and I can drag this some, but I still can't get up there. And I can zoom out, but it can get kind of wonky, right? Because I really have to zoom out, and then it starts getting too close, and I don't really like the look of that. So I'm going to go into like right about here. And instead of doing the zooming, I'm going to change the top of the Y. These right here are my ranges. So this tells me where the X values are. This tells me where the Y values are. And basically I need to make this higher because I started out with 500 milligrams of caffeine in my system. So I need to be at least 500. I'm going to go a little higher than 500 so I can then see it. And then I can kind of drag that. Now I have a better graph, but I can see what's happening with my caffeine. Right, so it's starting here at 500, and then I can even kind of like trace along and say like, okay, turn hour, there's that 250 mark, right? And then 125, and then I keep going down and down and down. All right, the next slide on the presentation is basically about your project. And so I know that some people were already looking at this, and that there is a link here. I think it should show up right embedded in your Pear Deck. Like you shouldn't have to go to another tab. I think it will be right on your Pear Deck screen. This has 10 real life examples of exponential growth. Several people have already asked, do you have to do these ones? No. You can do ones that you can think of yourself. You can do ones that we've done. Some problems we've done, we have done bunny growth. We had a bunny population, it was growing. We did a bouncing ball, right? And that was decay. We talked about interest rates on money, right? Edgar had his money. He started with, $400 getting 5% interest, and that was a pretty good deal. Somebody today wanted to Google like real interest rates, and on a savings account, he found that, the interest rate was like a savings account had like a standard like 0.04% growth rate. Just like, that's not very much. That means my multiplier would be 0.0004. But any of those are, so if you scroll down, bacteria grows exponentially. Mold on food, there's quite a few people who chose to do moldy food examples. Human population, also animal populations. We also have interest rates. We kind of mentioned that one. The like pandemics, the flu, right? And what we're dealing with right now, the coronavirus, obviously also grows exponentially. Ebola epidemic, that was an exponential growth curve. Invasive species, whether it was animal or plant, right? In our area, we have Scotch broom. I don't know if you guys know what that is. It's like, the plant gets pretty big, gets pretty thick. It has like yellow flowers on it. That's very invasive. They have a picture here of something that's called the water hyacinth. Fire, we had a pretty serious, California is having to deal with this more and more. And we had such a serious fire this last fall, but fire grows exponentially. Cancer grows exponentially. We also talked about like sales. Somebody last class mentioned the GameStop stock and how that grew exponentially, and that definitely did. One of the things to think about when you are doing your project and is that you want to pick your units of time, and your units of time are going to depend on what situation. So fire, maybe your unit time, maybe it's growing every hour, right? Fire can grow very quickly. If you're talking about your interest rate, that's more often, more commonly every year. Right? When we were talking about the caffeine in my system, that was an hour. It could be you're talking about something that's like growing every week. I'm trying to think of some of the other examples. So what I'm going to do right now is on the next slide. And before you go to do your project, I would like everybody to do this. And I'm going to be checking in and calling out names if I don't see you responding to this. Growth or decay, what will the starting amount be? And then what will the growth or decay rate of your situation be? So this is what you need to basically have a situation is like, what is it? And that will be your Y variable. And you, depending on your Y value, if you have fire, you're going to kind of say, is it growing every hour, every day? So I'm going to be checking right now. There's about 9 people who started, and I'm going to check in with people who might need this. I have somebody who's going to do fire and its growth. I have an infectious disease and it's growing, and they've got a great rate. Sea level increase over the years. And that's great. That's a really interesting one. I hadn't seen that one yet. Nice. And just because some people are already done with the Pear Deck part, on Google Classroom, you'll go over here, there's a project. You'll have a doc that's yours. There's also a doc that is my example. I chose like a fish population, invasive species called Asian carp. I did a Google search this morning. I was looking for something. And so I'm going to start responding to the chats that came through. Please keep chatting to me if you have questions. But you are either working on the Pear Deck to get some feedback on that, or you've finished your Pear Deck, you've moved on to your doc. And if at any point you want me to open your doc or check your Pear Deck, let me know. There's some people who are just kind of stuck on ideas, and I'm going to do that right now.
So after we're done filling this one out, are we allowed to start on our
Yes, for sure.
project? Okay,
For
thank
sure.
you.
Yeah, and you might check periodically because I am kind of like on the Pear Deck. I can see it really. The reason I had it on Pear Deck is because it's easy for me to sort of like give people feedback quickly, whereas the doc, I have to open docs and it's a little more unwieldy. So I using the Pear Deck to try to give quick feedback. Once you're on there, go ahead over and you can check. So for the project, I'm sharing my screen. So you are supposed to pick a situation that's exponential. Growth of a bunny population, a bouncing ball that's getting lower and lower. Could be money, you're getting more and more of money, sort of anything that's exponential. And then you're gonna pick like a rate. Sorry, just one second, let me see. I was trying to do. You're going to kind of pick two variables, right? So like I have an example on here. For mine, I chose like invasive species. I Googled it and I looked up that there's some Asian carp that's invasive in the Mississippi River. And so I said, okay, Asian carp is this invasive species. And then I just chose a starting value. I said, okay, let's start with 50 carp and their rate they're going to multiply by is 1.5. So you pick a start, you pick a situation, you pick a start and then a rate. And then you have to say like, how long is it taking? So I chose a year and then the number of carp and it's growing. And then I asked the question, how many carp will there be in 10 years? And then I had my initial value, my rate, and then I made an equation. And then after that, I filled in my table and then the graph. And I did the graph in Desmos.
So basically, we just have to make our own like problem.
Yep. And you can kind of look there. There's that link up here. This link has some websites. And that should help, hopefully.
Okay, because at first I was like, wait, what's going on?
Yeah.
Yeah.
Okay, yeah, so you're getting your own idea for some sort of situation that's growing exponentially.
Okay.
All right.
And then once we're done, we can go, right?
Yeah. And then if you need more help, I've got office hours and other times if you need more help.
Okay.
All right.
Okay, thank you.
You are welcome.